Greetings everyone. Today we're going to explore imaginary and complex numbers. Take a moment to reflect on our previous lesson. In our previous lesson, we were solving for x using square roots. Let's approach this problem the same way. I would subtract 10 from both sides. I would end up with x squared equals negative 10. I would try to isolate the x by square rooting both sides, which leaves me with square root of negative 10. This would result in no solution, as if I plug it in my calculator, I will get an error. So what can we do with a negative under the radical? Descartes realized in the 1600s that a value under a radical is still an important solution. So how can we utilize it even though there's a negative? So he created the number system of imaginary numbers. For example, if I have the square root of 1, I can take out the negative and it becomes an I. And then we can deal with the square root on its own. So square root of 1 is 1. Therefore, my resulting solution is just I. Make sure that when you write your I's, you put a little curve on the I to make sure that it's definitely an I. Make it a pronounced dot. You don't want it to look like a 1 or an 11 and have any answers be confused. We also have a second definition we need to make sure we know. The value of I squared is equal to negative 1. So for example, if I have I times I, that would be the same as I squared. I squared equals negative 1. I squared actually simplifies a lot of the problems we're going to look at and makes them easier to work with. Let's explore simplifying some radicals using imaginary numbers. In this first example, I take out the negative and create an imaginary number. This leaves me a square root of 25. I can then deal with the square root of 25 as it is 5. And typically with any letter in math class, we write the number first. So we would actually say 5i. Let's take a look at square root of 6. With square root of negative 6, I'm going to take that negative out. It becomes I. I'm left with square root of 6. In this case, square root of 6 does not simplify. So that's my answer. And let's take a look at square root of negative 40. I'm going to take that negative out, so it becomes an I, which leaves me a square root of 40. Take a look at square root of 40. Can I reduce that value? I can use good and bad roots, or perfect squares and non-perfect squares. Find a perfect square that divides into 40 evenly. You end up with 4 and 10. That leaves me with I, 2, square root of 10. But again, we typically write the number before the letter. So more formally, this would be 2i radical 10 as my final answer. Let's look at another example. I'm going to take the negative out and create my imaginary number. 48 reduces. Let's separate it into a good and a bad root. In this case, you want to pick the largest good root, which is 16. 16 times 3 gets me to 48. Now, yes, I realize that 4 also goes in 12 times, but then we'd have to break 12 down again, so that's just extra work. So stick to the largest good root. Square root of 16 becomes 8. Now, when I have numbers and letters written next to each other, that implies multiplication. So I need to simplify one more step by multiplying that 8 times the 5. That leaves me with 40, an I, and a radical 3. Let's take a look at one last simple example of reducing radicals. We're going to take the negative out and create our imaginary number. Because I have a fraction, I'm going to separate these radicals. Similar to our previous lesson, we need to remember to rationalize the denominator. To rationalize the denominator, we're going to take top and bottom by the bottom radical. This leaves me with a numerator of I square root of 30. Square root of 3 times square root of 3 is square root of 9. But square root of 9 equals 3. I can't simplify the 30 and the 3 because one is under a radical and one is not. So they are separate values. They're not like terms in the end. Let's explore complex numbers. In complex numbers, you have a real part and an imaginary part. So for example, this is a complex number. I have a 1 plus a 2i. Complex numbers need to be written in standard form. Standard form for a complex number means the real part followed by the imaginary part. So what do I mean by that? If I had the number 2 plus 3i versus 2i plus 2. 2 plus 2i is in standard form. 2i plus 2 is not in standard form. Let's look at how we simplify complex numbers. When you look at these examples, you're going to think of the I as any other variable as far as distributing, multiplying, adding, subtracting. Think of that as like terms. If you relate it to an x, it'll help you remember the rules that we're applying. So in the first example, I have parentheses and I'm multiplying. Therefore, I'm going to distribute. 3 times I gives me 3i. Bring down my sign. I times I is I squared. If we look back at our rules and the definitions, I squared is equal to -1. So I can say subtract 1 or I can say add a -1. But either way, I replace the I squared. Now we have to write it in standard form. So the -1 comes before the 3i. Let's look at an adding question. If I'm adding, in this sense, nothing's being distributed. There's no negatives or numbers. So the parentheses are actually obsolete in this question. So I'm going to add my like terms. 3 plus 4, 2i plus -6i. 2i plus -6i gives me -4i. We need to make sure it's written in standard form. I have the real part followed by the imaginary part, so I'm good to go. Let's take a look at multiplying. Here I have a complex number times a complex number. Think of it similarly as a binomial times a binomial. We would follow very similar rules. So in this case, we're going to use FOIL, or double distribution. FOIL tells me what pieces I'm multiplying. The first term times the first term, the outer term times the outer term. 3 times -5 is -15. I times I is I squared. The inner terms are being multiplied as 6 times 4. And the last terms, -5 times +6 gives me a -30i. We have to remember our I squared rule. If I rewrite this, this I squared becomes -1. -1 times -15 gives me +15. So essentially, you can think of it as a shortcut. The I squared becomes 1 and we change the sign, or you can think of it as it is with multiplying by -1. Now we can combine like terms. 15 plus 24, those are like terms. I end up with 39. 12i minus 30i are like terms. We end up with negative 18i. Make sure it's in standard form with the real part followed by the imaginary piece. For your homework, make sure you check Google Classroom. In class, we worked on some marker boards, and in our next class, we're going to work on solving equations with imaginary numbers.